Hello, it's Raphael from Hypermode. Today we'll explore a new feature of Dgraph product and the capability in the V24 to support vectors and vectors embedding and similarity search. So we'll see how to add this feature on an existing graph. And it's a key feature to support all sorts of AI use cases, such as RAG, retrieval augmented generation, but also classification and similarity search. So let's start with, I have a Dgraph instance running V24 here, and I can show you the schema that is deployed. This schema has a product, purchase, and user, but we'll focus on the product, which has ID, description, title, basically. So let's see, here we can introspect the schema, and we'll see that in terms of query, you see a get product, a query product, and some mutations too. So we can just query to see the number of products there. We have 200 products, and we just ask 3 of them. And you see they have some titles and description here. So here the goal will be to add some vectors and to do some similarity search. So let's see how to do that very quickly in Dgraph. So I will be using something we shared on the PyDgraph repository, which is the Python client. And if you go to examples, you will see that we have an embeddings and a compute embeddings Python script. I will use this script. So what I have to do first is to declare that the product has now another field. Let's call it characteristic embeddings or embeddings, whatever you want. It's an array of floats, but to be treated as a vector, we mentioned that it will be an embedding. And in terms of index, we'll use the HNSW index using the Euclidean distance. So that's it in terms of declaring that one predicate would be a vector. You can have many embeddings on the same node, which is really interesting because you may have one for text, one for image, and get multi-model search, or one with an Hugging Face model, one with OpenAI model, depending on your use cases. Let's push this schema to Dgraph. It's done. So we should be able to see what happened on the GraphQL API itself. You'll see that okay, so let's push the schema to the Dgraph instance. It's done. So we can now go to the introspection and see that we have new queries generated. The query similar product by embedding. So we can provide a vector and search for similarity by this vector. Or we can start with a node which has a vector and search similar vectors using similar product using the vectors too. So first we need to populate the vectors, of course, because let's go to my query and we can ask the new field here, and obviously this field is empty. That's where and obviously the characteristic embedding is empty. So let's go to using the script that I mentioned. So we can go to the embedding definition here. So the script is working with some definition of embeddings. So you see this embedding definition here for product, and I want to compute something for the characteristics embedding predicate. And I will use Hugging Face model and the all-mini-LM L6v2 model. So you can do a DQL query to retrieve fields on each node and use this in a message template to create a text that will be used for the embedding. So let's start with a simple embedding using the title. And we can just compute the embedding. And we can ask, so we can just compute the embeddings on every node. So the script will ask you to confirm that you're on the right instance. And if you want to just generate the missing predicates or every, so we'll generate everything. So we can start the script. It will ask to confirm the Dgraph instance, and if you want to compute everything or just missing embeddings. Okay, so it's done. So we had 200 nodes and we had 200 embeddings generated. So we can verify that into query, just ask for a few of them, and you see now every node has a vector associated with it, which is the embedding of the title. So we can do a test now for similarity. So we can take this two-way covers 10 ping for Samsung Galaxy, and we get the ID of this node, and we can build a similarity search. We'll get an ID. And for the similarity, you just specify which predicate will be used to get the vector and how many similar nodes you want to get. So we also ask, with this, we'll just ask for the title first. And we can ask for the vector distance, which has been generated by Dgraph when we have an embedding. Okay, so we can query that. And we'll remove the embedding of the queries. So we see that, for example, on this case, so the first one is itself, so the distance is 0. But interestingly, the second one, it's also covers 10 for Samsung Galaxy, violet, different color. This third one is a stand cover for a tablet, so pretty close to. And we can explore a bit. For example, let's take 10 of them. You can now see how good is the similarity with the vectors you have added. So that's it. We have added in a minute a vector embedding, compute the embedding using an Hugging Face model, and use the similarity search in Dgraph. And now you can start using Dgraph as a data source for many AI projects and get the data, use OpenAI to generate text from there, do similarity search, classification, all sorts of very interesting use cases. Thanks.